This is probability non-calculator question. So first of all, we got a bag containing 5 white ball selected without replacement. So we just fill in the ball. So the two sides should be equals to 0. So taking one ball out, there's still 3 white and 7 ball left. And the other one will be taking one green out. There's still 5 white, 5 green, and only 2 white. Nice and easy with the 3 points. And then exactly one ball selected. So we have green, white, and then white, green. So we have 5 over 8 times 3 over 7 plus 3 over 8 times 5 over 7. Because it is just non-calculator, so I got 15 over 35 plus 15 over 35, and end up we got, no, 42, sorry. No, 56, sorry. So, and then I got 60 over 56. To simplify it, I got 15 over 28. Need to be careful, but there's our 6 marks. Here's the second question. It's a arithmetic sequence. First term 8, second term 5. So the common difference D equals to 5 minus 8. The one after minus the one before. So we got 3 as the answer. Sorry, negative 3 minus. Alright, and the 10th term with the Tn equals to 10th term, so I just use the 10. Equals to the first term plus n minus 1d. So I got 8 plus 9 times negative 3. So 8 minus 27. I should get negative 19. Last but not least, the sum of the 10th term. So S10 should be equals to 10 minus 2, first term, plus last term. So, and then I got negative 55. Another E. Here we have a function question. So they give me a function that is the domain, and there's a point line on the graph, which is negative 2, 0, and 4, 7. Alright, so the question on the next page, let's see. Write down the range of it. So we are looking at it, the range means this bit. So we have 0 to 7. So I will write down A, 0 inclusive, Y inclusive 7. Some people will use the segment per se. Alright, Y equals to negative, Y, F2 and F inverse 2. So you write when F equals to 2, so F2 equals to 3. And F inverse 2 means that the Y equals to 2. So we look for Y equals to 2 for X, which is 0. So that will be 0. Pretty easy for that one. And then now up on the grid, sketch the F inverse. So we get back to the graph here, and then we need to sketch the inverse. So usually I will draw down a line just in case I miss anything with X equals to Y first. To show that I know it's a reflection. So when X equals to negative 2, Y equals to 0. So I do an inverse here. 2, 0 become here. And then when Y equals to 3, X equals to 2. And then the final point 4, 7, and then it becomes 7, 4. Now join the dot. Alright, so that's what we want, all the points to be inverse, X and Y interchange, and that will be done. Nice and easy. Here's another question there. So the other page is just working, so I might as well work here. And I'm going to use this pencil. Alright, so we want the third side. We got 2 sides included angle, so we will have to use cosine rule. C equals to square root a squared plus b squared minus 2ab be cosine pi over 3. Alright, so we got our 9 plus 64 minus 24, 48. Cos 61 to root 3 is 1 over 2. So now we got 9 plus 64 minus 12. Then we will have square root 49, and then we got 7. Yeah, a proof. Remember, if you cannot work out the proof showing that, use that from there onwards. So now we got the diameter with the semicircle, so I put that here. This is 7. This is what we find there, and then we got the perimeter. So this plus this with the shape. So the perimeter is 7, so the radius will be the circumference. The circumference will be pi d. So we will have 3 plus 8, move up a bit, plus pi d divided by 2. So now I have 11 plus 11 over 2 pi, exact value, done. Another 7. Here come another function question. So we got a function here. It's a bit blurry. Let me fix something. Alright, so yay. So we got a function fx and gx here. So they want g of x. So we just substitute whatever x in g to put f in g. So equal to 2, 1 plus e negative x plus b. And actually that's fine, but then if you want to simplify it, that's done. So that's 2 marks already. So, and then b, given that lim x tends to positive infinity for g of x equals to negative 3. So we just reply it. So we have 2, 1 plus e negative x plus b equals to negative 3. Since this tends to infinity, that will become really, really small. E negative x tends to infinity. That gives us 1 over ex, right? When x tends to bigger and bigger and bigger, the whole function will get so small that it's close to 0. So we will leave it as it is to become 2 times 1 plus b. That gives us 2 plus b equals to negative 3. Throw this to the other side, b will be equal to negative 5. Pretty easy. Moving on, another function question, but this time with a parabola. It's quadratic and the maximum. So let's see what we have. So a, b, c, d. This is a parabola. So this point should also be negative a, because the other side flipped at a, b, right? So yes, the notation is not really right. So to avoid the confusion, we take it away. So if this is xy, this is negative xy. That looks better. So now we're going to have the maximum area there, because area doesn't have a limit. So we have the distance here, x, and the distance here will be y. So we will have the area will be x times y. Since y is here, so we will have x times 1, right? So, and then we want the maximum area, so we want the area dx. Right? So we have 15 minus 2x squared. Put that equals to 0 to find the maximum. Then we have 15 equals to 2x squared. 15 over 2. Actually it's 3. 15 over 3 equals to x squared. No, 15 over 3 is actually 5. So I will drop that off. So that will become 5. X should be equals to plus, so minus 5. Root 5. And since a is at the negative side, so the coordinate of a should be negative root 5. Another 7 points. Here is the log question. I love working with log. So we have 2 log equals to log k, 6x minus 3x squared. We want exactly one solution, so be careful with those. So rearranging it, we will have k squared equals to 6x minus 3x squared. So we throw that to the other side. 0 equals to negative 3x squared plus 6x minus k squared. Remember, k is a value here. K is bigger than, so I could just count it as a constant. With exactly one solution, which means that discriminant equals to 0. Discriminant equals to b squared minus 4ac. So we have 0 equals to b squared, 6 squared minus 4 times negative 3 times k squared. Negative k squared, so I put it in the front, become positive. So now we got 36 plus minus 12k squared. Throw everything on the other side. 36 divided by negative 12 equal to k squared. Positive. No, sorry. Do it like this. K squared equals to 36. K squared equals to 3. K equals to plus or minus root 3. Since we got k have to be bigger than 0, so k equals to positive root 3. And that's our 7 points. I really love log question. Now we get to the long question. So we have a function here. And then we want to show that f dash 1 equals to 1. So we have fx equals to x squared minus x. So f dash x should be equals to 2x minus 1. So f dash 1 will be equals to 2 times 1 minus 1 equals to minus 1 equals to 1, which suits our needs. And now the tangent have format P. So I'm gonna normal here. This should be the normal, and the tangent, this is the tangent, which 90 degrees over like this. We want to find the equation of L. So we want P is 1, 0. So we know that f dash 1 equals to 1. So the normal at x equals to 1 equals to negative 1. All right, because we negative it and flip it. So we got negative 1, and then we got the point here. So y equals to mx plus c. So 0 equals to negative 1 plus times 1 plus c. So 0 equals to negative 1 plus c. c equals to 1. Therefore, our equation is negative x plus 1. Right, so another 3 points there. Now, the line of L1 intersects another point, which is this point. Find the x-coordinate of it. So we have 2 equations. I need another piece of paper. So, recap. We have y equals to x squared minus x, and the other side is y equals to negative x plus 1. So I want the intersecting point of this 2 here. So I will equal the both sides. So x squared minus x equals to negative x plus 1. So put it to the other side. Everything to the other side. Negative 2, minus, gone. So negative x squared equals to 1. X equals to plus or minus 1. Plus 1 is here. So the coordinate of Q x-coordinate of Q should be negative 1. Right, and then the area of the region by these 2 lines. So I want this bit and this bit. So that will be a integration of the top and the bottom. So we make sure we minus that first. So we will have integration, the 2 point, 1, negative 1. The top bit minus the lower bit. The line is here, so we have negative x plus 1 minus x squared minus x dx. So we minus it first, so negative x plus 1 minus x squared plus x dx. So that gives us 1 minus x squared dx. Integration x minus 1 over 3x cubed, 1 negative 1. So I will have 1 minus 1 over 3 minus 1 plus 1 over 3. So I have, this is negative, so I will have minus minus plus. So I have 2 minus 2 over 3, that gives me 4 over 3. And this is the area. That's another, how many points? 16 points for that. Here's a vector question. Yeah, not my favorite, but we still have to do it, yeah? So we want to find AB. So trick is B minus A, B minus the one after minus 1. So I have negative 1, 3, 3, minus, negative 3, 4, 2. So all you get will be AB. So we have negative 1 plus 3, 2, minus 1. Oh, sorry, I copied it wrong. Yeah, should be right. 3 minus 1 is 1. Yeah, it's correct. So that's our A. Find the vector equation of L3. So we will have one of the points, so x, y, z equals to any point. I'll use A plus t to negative 1, 1, the direction vector. Another total 3 points in hand. So now the P goes through this point. So we will have 3, 1, P equals to negative 3, 4, 2 plus T 2, negative 1, 1. So in one of the equation, we have 3 equals to negative 3 plus 2T. We need to find T first, and then we will be able to find T. So we will have 6 equals to 2T, T equals to 3. Then we put it back to it. So P equals to 2 plus 3 times 1. So we have 2 plus 3 give me 5. So P equals to 5. Nice and easy. But I'm running out of space, so I need to have paper to do number C. C, the point D coordinate, get back to D here. Point D, the coordinates is this one, given that it's perpendicular to L. So we need to find the direction vector first. So I will get CD, the one behind minus the one before, square, 0, Q, minus, 3, 1, 5, which we find before. And then, because it's perpendicular, it should be dot product with the direction vector should be equal to 0. So I will have Q squared minus 3, negative 1, Q minus 5. But the Q is a bit too big. Let me get it smaller. Dot 2, negative 1, 1 should be equal to 0. Rearranging it, 2Q squared minus 3 plus 2 plus Q minus 5 equals to 0. So 2Q minus 6 plus 2 plus Q minus 5 equals to 0. Square that. Rearranging it, so 2Q squared minus 4 plus Q minus 9 equals to 0. Now I need to have my quadratic equation, or if you use the cross method. Is it 2? Plus, yes. Yeah, so I will have no, something wrong there. Let me check it out. Right, so I should get it right. What happened? Something wrong. Negative. Oh, sorry, this is a positive. That's why. 1 times 1 is 1. All right, so now problem solve. I got negative 10 here. So now I could have a cross method. So I have 2, 5, 5, 2, yeah. So I need a negative somewhere. So I need to have a here. So I will have 2q plus 5 and q minus 2 equals to 0. So q should be equals to negative 5 over 2 or 2. And that's our answer. Okay, this is an exciting geometric sequence long question. It's not always happening with a long question, but I like that. It's really exciting. So we have a length here, A to B. Total A to B is 2 cm. But then they have been chunked into P squared, and so on. And definitely it's in an infinite segment. So we know that P is between 0 and 1. So this could be an infinite sum. So we will have P plus P squared plus PQ plus equals to 2, which means that we have U1 P over 1 minus R. The R is the one after divided by 1, so 1 minus P equals to 2. So flip this over, P equals to 2 minus 2P. Throw it to the other side, so we got 3P equals to 2. P should be equals to 2 over 3. Nice and easy. So now, coming to the second part of the question, now this is another one diagram with similar cases, k, k squared, and so on. However, this time, with the first 3 square and so on. Now, the total sum of the area is this one. So that is a bit tricky here because we got the bit of those. So still, we have k and k squared with those. This is an infinite sum. But then, we need to find the area. So this is k and k, this is k and k squared. So this time, the u1 is k squared. So k squared plus k cubed plus k cubed times cube is q to the power 6 plus forever equals to 9 over 16. Now the first term is k and the r is k squared. So using the infinite terms again, we will have the k as k squared. So we will have k squared over 1 minus k squared equals to 9 over 16. Again, throw everything on the other side, we got 16k squared equals to 9 minus 9k squared. This one throw to the other side, we got 25. So we have k squared equals to 9 over 25. K should be equals to, it's a positive value, so it's 3 over 5. Now we have k, we need to find b. The length is b, so we have to square root it, and then we find the bit of those. So what we can need to do is r equals to k, which is 3 over 5. And the infinite sum equals to b, which is 3 over 5 over 1 minus 3 over 5. Let's give us 3 over 5 divided by 2 over 5. Cancel that out. 3 over 5 times 5 over 2. That gives us 3 over 2, and this is the value of b. Nice and easy. Bingo, 14 points.